So I started using these little thermal resettable fuses, which I wanted to show. So pretty cool. And one such use would be a little power supply. So here's a power supply I've had for a while, and I originally had made this with 7 18650s in series to just bring the battery voltage up to about 29, 30 or so volts, and use that through a buck driver. Since then, I've decided to use a buck boost arrangement. So in here, basically, I've got a sort of a semi-standard battery pack, which is sitting at 12.5 right now, and that's 3 18650s in series. To where if I wanted to, I can add more parallel banks onto that. But I'm running that through a BMS board. So that is being boosted to about 30 volts through a boost driver, and then stepped down through a buck driver, which is what these knobs are attached to. So that makes it so I can easily just recharge it through another buck circuit, like these I use a lot, and just set it to 12.6, no more than 1 amp output. So the way this is set up is it's got that BMS board, which has a 25 amp shutoff. So if you were to dead short the battery, then it will immediately shut off and will not see a load again until you put the charger back on it. So that's how that works. But since the buck driver I'm using is really not good for over a few amps, it will go into a shutdown mode in a direct short scenario. But if I'm pulling maybe 4 or 5 amps through here, it's going to work. That is until it overheats, because it doesn't have a heat sink. So the goal there was to just have a little shutoff, which I'm using here with these little thermal switches. So these are pretty cool. I guess they're mainly for automotive use, but this is what the inside looks like, and it's essentially just a little metal strip here which will bow out with heat. So with enough heat, that's going to separate, and it's going to cause that little spring in there to eject this plastic piece, which then separates these two pieces. And I've got one here that is rated for 5 amps. Now the thing about these fuses is these are, you could call them slow blow, because they're not going to immediately trip as soon as they see that current. It's a temperature thing. So until this thin metal strip here actually gets hot enough to bow out and separate, then it's just not going to do anything. So right here on this power supply, I've just got my output shorted together, and the supply is on right now. The output is not engaged, so I'm going to put it to the lowest voltage that it will run at, because it's going to drop anyway. And I'm going to cut it on in a short scenario, and we'll see if that thing pops out. So I'm going to, let's see, I'm going to cut it on. You can see, due to the voltage drop, it is sending some current, but it's not a whole lot. I've actually got this, the constant current all the way down. So as I cut that up, you see I cut it up a little bit, and as soon as I did that, this thing popped out. It was feeling that current, and see it's now, it is now on still, but the output is disengaged. So that little thermal resettable fuse there is basically in line with my output. So just to kind of show again, let me cut that all the way back down. Let me cut that back down, and then I reset the fuse by just popping that guy back in there, and now I can cut it back on and do it again. So let's see if we can raise that current a little bit again. There it goes. So just for good measure, let's see what that's doing on a meter. Alright, so we got this DC clamp meter on to read the amps going through the leads here, and we're just going to cut it back on the setting it was before to see what it's pulling. Now immediately that thing shot up into high amperage before the constant current setting kicked in. So I'm gonna slowly crank that up to see what we get. Oh, didn't take long. Did not take long. Let's try a different voltage here. Let's crank the voltage up just slightly. Let's put it on about 2.5 volts. And maybe if we crank the voltage up a little bit, we'll have a little more adjustability on the constant current mode. All right, so we're back up. Let's see if I can zero that out a little better. That's about as good as it's going to get. All right, so back up about 3.5 volts, CC all the way down. Cut it back on, see what happens. So we're drawing about 300 milliamps, about an amp now. A little more adjustability. So let's bring it to the point. Let's see how quickly this will disengage at an actual 5 amps. So we're almost there. So we're pretty much at our mark right now. We're at 5 amps. That fuse has to have about 5 amps going through it. However, it is rated between 12 and 24 volts. So unless you're pulling over 50 watts through it, it's probably not going to immediately disengage. So let's see when it does. Alright, so something close to 6.5 amps, that thing finally kicked off. So technically speaking, it is doing something. It might not protect circuitry that you're trying to protect if you don't want overcurrent, but for my purposes here, I don't want to burn out any heat sinked boards such as this buck driver here, and that basically just provides an added level of protection there. It also will show you whether you've got good splices and joints in your setup. So you can see basically, cut it back on, pop that back in, reset it, and do it again, bring it back up to about 5 amps. You can see I'm pulling 5 amps. Doesn't really look like the battery's struggling a whole lot. I mean, I suppose it is a little bit. So we're close to 6 amps. Still hasn't triggered. Alright, so there we go. So that's about as good as that's going to get there. So like I say, these little guys are pretty nifty. I have some in various sizes. This one's 7.5 amps, so you can assume that if I was to use this in its place, I would probably be able to pull closer to 10 amps or so before this thing kicked off. But yeah, very nifty for these builds.